So for another proof technique, we're going to discuss, this time, a proof by contradiction. Don't confuse that with a proof by contrapositive. The names seem similar, but this is a totally different kind of proof technique. And it's actually a very nifty one and quite powerful. This content is contained in the book of Proof, chapter 6. And proofs by contradiction come in a couple of different flavors. So the first definition that we are going to look at is a proof by contradiction of just a statement P. So previously we were looking at things like proving P implies Q. Here I'm looking at a proof by contradiction of just a single statement P. And the way that a proof by contradiction proceeds is as follows. You assume not P. So you assume that not P is true. Then you need to derive a contradiction. I'll define a contradiction in just a second. And after that, we can conclude that P is true. So what is a contradiction? It's any sort of statement that can't possibly be true. So for example, we could have something like C and not C. This is a statement that could never possibly be true. You can try any truth value for C here, and this statement will never be true. This is a contradiction. So this proof technique here is nice because it gives you a little bit more to work with, because you can assume that what you're trying to prove is false. After that point, though, it requires a little bit of creativity, because the contradiction that you're going to derive, you might not know what it is. You have to go out and you have to find it. But then after you find that contradiction, you can conclude that P is true. And why can you do this? How does this proof technique actually work? Well, again, to show how it works, we can go back and look at a truth table. Thankfully, this truth table is going to be very small because we only have a single variable P. And let's consider P and not P. So P can only take on values of true or false. And then not P, all I have to do is flip these, false and true. And remember, we're trying to prove that this statement P is true. So what we want to show is that we're in this first row. And how does this proof technique help us show that we're in that first row? Well, we're assuming not P is true. So we're assuming this second row. We're assuming not P. And if we assume not P and then derive a contradiction, well, that contradiction, well, that statement it can't possibly ever be true. So that means that this row would then be eliminated. We want to eliminate that second row by showing that it can never be the case. And it can't be the case because logic is consistent, and so you can't have any of these contradictions laying around because they can't possibly be true. So if we derive a contradiction after we had assumed that not P is true, we can scratch out this row, and then we know that we are in this first row here, and in that row we have P is true. And that's why we can then conclude that P is true. So that's the basic structure of a proof by contradiction of just a single statement.